Alright, ladies and gentlemen, so in this video we are continuing the vector discussion, but specifically the discussion about velocity, acceleration, speed, position, our motion, direction of motion, and we're going to look at another example. And so the goal remains the same, is to understand vectors as each of what I just labeled. Understand vectors in terms of position, velocity, acceleration, and speed, and the relationship between all of them. So the first thing says we have a particle, it's moving in an elliptical path, and this position at any time t greater than or equal to 0 is given by the position function 4 sine t, 2 cosine t. So the first part says, hey, what about finding the velocity and the acceleration vectors? So first and foremost, this is going to be kind of a review from our last video, in which we just basically had, hey, here's the position. Derivative of position is velocity. Derivative of velocity is acceleration. So let's go ahead and take a look here first and foremost. So for part A, if position is equal to 4 sine of t, and remember, we can put position in our parentheses instead of those arrowed brackets, just because it's a point. Really, that's all it is. Either way, it works, honestly. All right, so part A. So let's go ahead and find our velocity. So velocity is going to end up equaling the derivative. So now we're going to put it into brackets here. So the derivative of 4 sine of t, 4 sine of t, will end up giving us 4 cosine of t, since there's no inside function to deal with. And then the derivative of cosine of t, or 2 cosine of t, well, derivative of cosine is negative sine, so it'll be negative 2 sine of t. And so then what about our acceleration? Remember, acceleration is the derivative of the velocity, and so cosine derivative is negative sine. So we have negative 4 sine of t this time, and then a negative 2 sine of t. Well, sine's derivative of cosine, all right? And so we just leave the negative, and we're going to end up having negative 2 cosine of t. So it takes care of part A. Now what about part B? Well, part B says, what about finding the velocity, the acceleration, the speed, and the direction of motion when t is equal to pi over 4. So now we're just giving a value for t. We're trying to find out, hey, what is the velocity when t is pi over 4? Well, the velocity when t is pi over 4 is just the substitution of 4 times cosine of pi over 4 and negative 2 sine of pi over 4. And so our velocity vector can be represented. Well, let's take a look here. Well, we have pi over 4, which is going to be square root of 2 over 2 multiplied by 4. So we're going to end up with 2 root 2. So this equals 2 root 2. And then once again we have 2 root 2 square root of root 2 over 2 for sine of pi over 4 multiplied by negative 2. So that'll just leave us with a negative root 2 in there. And same thing goes for acceleration. You want to go ahead and sub in pi over 4 for acceleration and say we've got now negative 4 sine of pi over 4 and negative 2 of cosine of pi over 4. So again, we're dealing with root 2 over 2. So negative 4 times our root 2 over 2, same thing, gives us 2 root 2, but it's negative this time. So negative 2 root 2. And then for our cosine function, when we have root 2 over 2, but it's negative, and so the 2's will cancel, and you'll end up just with a negative root 2. So there is our velocity and acceleration, specifically when we are at pi over 4. But what about speed? Well, remember, guys, speed is the magnitude of velocity, the size of the velocity vector. And so speed in this case will equal the magnitude of the velocity vector. So we're looking at, in this case, the distance formula utilizing our velocity vector. So we have 2 root 2 squared plus negative root 2 quantity squared. And so we'll end up with, let's see here, 4 times 2, so we get 8 plus 2. So we end up getting root 10 in the end, right? Yeah, root 10 in the end. So there is our magnitude of the velocity vector, or speed. Once again, the magnitude of the velocity vector is speed. Okay. So let's take a look as we kind of continue to focus here. Now, part C. Now, part C, it says, sketch the path of the particle and show the velocity vector at the point 4, 0. All right, at the point 4, 0. So I'm going to pause the recording at the second, all right, and I'm going to go ahead and graph this so I don't waste time in the video graphing it, and then once it kind of continues on, it'll catch back right up to it. Okay, so what does this graph look like? I went ahead and graphed our elliptical path that we see here. And again, we do this by putting it into parametric mode. And I just simply graphed 4 sine t and 2 cosine t here. And so for part C, it says sketch the path and show the velocity vector at the point 4, 0. Okay, so we want to look at what the velocity vector looks like at point 4, 0. Well, obviously, here is our point. Let's get a red in here. So our point 4, 0 here. So it wants to know, what does the velocity vector look like? Well, what we're trying to figure out basically is, what is the vector for velocity when t equals 4 in this particular case? So let's find that out for a sec. In our example, we knew that velocity, we'd already said that the velocity vector was 4 cosine of t, and then we have, let's see here, negative sine of t here, okay? And so if here is our velocity vector that we are dealing with, well, what are we really looking at? What are we substituting in, per se, for each of these particular examples, okay? Well, let's think about it for a sec. At each of these particular points, at the point 4, 0, what does sine of t actually equal in this particular example that we're dealing with, right? And so let's say we're dealing with our point 4, 0. So the point at 4, 0. That means our x value is 4 and our y value is going to be at 0. And remember, our position function originally, our position function r of t was originally 4 sine of t and 2 cosine of t in this example. So, okay, if this is x and this is y, that means what is sine of t when x is 4? Well, 4 equals 4 sine of t. And so divide through by 4, sine of t is equal to 1. And then on the other side of things, when y was 0, because we're dealing with the point 4, 0, we have 0 equals 2 cosine of t. So at this particular point, cosine of t equals 0 as well. Well, now how does that benefit us? Because now we can actually substitute this into our vector, our velocity vector here. Because if sine of t is equal to 1, let's change colors so we can kind of show the substitution. All right, so our velocity at this case will be 4, but sine of t at this point 4, 0 had a value of 1. And our negative 2, oh, I'm sorry, hold on guys, I'm switching these up on you a little bit. I'm putting cosine first. Cosine of t was 0 in this case. Cosine of t was 0 in this case. And then we had our negative 2 multiplied by sine of t. And sine of t was 1 at this point. And so the vector itself can be said that, hey, at 0, negative 2 is what our velocity vector will look like when the point of xy is 4, 0. So let's kind of show this. Well, if I'm going no units left or right, and I'm only going 2 units down, well, simply put, then our velocity vector, if this is 2 down here, negative 2, so I'll extend it out a little bit longer, there's what our velocity vector looks like at the point 4, 0. All right? And once again, let's reiterate what we just did. We went ahead and we had our velocity already. We already had our velocity vector, 4 cosine of t, comma, negative 2 sine of t. We kind of had to think to ourselves, all right, the position function r is currently set at 4 sine t, comma, 2 cosine t, or x, comma, y. Well, at the point 4, 0, x equals 4 and y equals 0. So we substituted them in just to simply solve for sine of t and to solve for cosine of t. So we could substitute those values of 1 and 0 into our velocity vector for cosine and sine of t. And that allowed us to see what the description or the look of our vector was at that particular area. And then kind of to wrap up, I guess, part D of our question here initially said, does the particle travel clockwise or counterclockwise around the origin itself? Well, you're going to see that obviously it travels in a clockwise position, and that's kind of shown from the previous one. If it's going downward at this point 4, 0, that means it's going to continue around this way for our clockwise position around, right? If it's shooting downward, it's in that downward motion at 4, 0, that's going to kind of go in that direction versus the opposite clockwise, okay? All right, guys, that's going to wrap it on up for this video, and we're on to the next one.